Hello, this is Akanksha Thorat from VIT Chennai. Today we are going to see the process creation. For creating process, we use the fork. Fork basically makes a duplicate process of a current process. The new process gets the different process ID. It is nothing but the process ID of the old process, that is the parent process. The following is the syntax of the fork. Its return type is integer, that is PID underscore T fork and the no argument. It returns the process ID on the success and it returns the -1 on the error and it specifies the error number. Then next is the vfork. The basic difference between vfork and fork is that when a new process is created by using vfork, the parent process temporarily suspended and child process might borrow the parent process address space. This process is continue until the child process exit, either called execv. Then parents process will be continue. This is the syntax of the vfork system call. The next is the exec. This exec call replaces the entire current process with the new program. It loads the new program into the current process space and runs it from the entry point. The syntax of the exec is int, return type is int and the name exec, and it accepts the path of the another program which we want to execute in the current process and the argument. The next is the wait. The wait system call blocks the calling process until of its child process exit. The execution of a wait process is have two possible situations. First is nothing but if there are at least one process is available when the wait call is get made, the caller will block until one of its child process is exit. At that time the caller resumes the execution. And the second situation is if there is no child process running when the call is made to wait, then wait has no effect at all. The difference between wait null and the wait to 200 millisecond or microsecond. The wait null, you only wait for any child to terminate, and the wait to 200 is nothing but wait for a particular time to execute a child. After time is goes out, the parent process start execution. The following is the syntax for the wait. The return type is PID underscore T wait in bracket status, it is null. The next is the wait PID. This system call suspends the execution of the calling process until a child specified by PID argument had changed the state. By default, wait PID wait only for terminated children. The following is the syntax of the wait PID. Its return type is the PID underscore T wait PID, then the process ID and the status and the option. The next is the exit. This terminates the current process. The function underscore exit terminate the calling process immediately. Any open file descriptor belonging to the process are closed. Any children of the process are inherited by process 1. Init and the process parent is sent to a single signal. The value status is returned to the parent process as the process exit status and can be collected using one of the wait family of calls. The function underscore exit is equivalent to the exit. The following is the syntax for the exit. Hash include return type word underscore exit and status. The return value of the exit system call is nothing. This is the program where we use the all system call. Here we include the UniSTD and STD library. Here we declare the execvp. This is nothing but the we calling the exec function system calls to execute the another program into the current process. Here we declare the one variable n is equal to 5, and here we specify the character for the execvp function, because here we give the path of the file, that is the ./exp. exp is nothing but the name of the another file, and the argv, that is the null. Then we declare call the function fork. If the fork is created successfully, then we call the vfork. By using vfork, we execute the this logic. This logic is for the calculating the factorial of the number, that is the 5. Here we provide the weight in bracket null, that is the parent is wait for the child's execution. Then after the execution of the child, the parent process is get called. Then here we print the output of the vfork process, that is the factorial of the 5. And in else part we actually call the execvp, and we provide the path of the particular another program which we want to execute in this current process. And here the actually another program is gets called. The another program is nothing but the exp.c. Here we calculate whether the given n is the even or odd by calling this function execvp. This exp.c program gets executed and it's print the output whatever it may be. Here is the actual output of the above program. The vfork is called, and in vfork the factorial of the 5 is calculated. After that fork is gets called, and after that exec function is called, and it print out the result that 5 is odd number. That's it. Thank you.
Hi friends, previously we have seen how to create the process using the fork system call and exec, vfork and wait. Here is the cycle that shows how to use the fork system call to change its ID using exec. Firstly, the new process is created because an existing process makes an exact copy of itself. This child process has the same environment as its parents, only the process ID number is different. This process is called a fork. After the forking process, the address space of child process is overwritten with the new process data. This is done through exec call of the system. Fork and exec mechanism thus switch an old command with a new, while the environment in which the new program is executed remaining same, including configuration of input and output devices, environment variable and priority. The mechanism used to create a Unix process, so it is also applies to the Linux operating system. Even the first process is init with process ID 1 is forked during the boot procedure, so called bootstrapping procedure. This scheme illustrates the fork and exec mechanism. The process ID changes after the fork procedure immediate. There are a couple of process which init become parent of a process, while the process what not started by the init actually. The previously we have seen when a process ends normally, the program returns its exit status to the parent. The exit status is a number returned by program providing the result of the program execution. The system of returning information upon executing job has its going in the programming language which is Unix. The grep command is written -1 if no matches are found in a program upon which and here we saying after init we called the for, and after calling the for the process id will be changed. Using this exec we can execute this process, and if there are no matches are found, then grep will be returning -1. The exec is basically used for the creating process, and when the new process is arriving, then it replaces the old process and execute a new process. It's work of exec. Thank you.